Today we're talking about section 11.5, and that's common logarithms. Common logarithms are the logarithm button that you find on your calculator that says log. Common log has a base of 10. So if I say the log of 100, basically what I'm saying is what do I have to raise 10 to equal 100. So if you just put in your calculator the log of 100, you should get an answer of 2, actually. Okay, so anytime you don't see a base value there, it's an understood base value of 10. So it's got great application for it because just about any other logarithm can be done using a common log. But let's say I want to know what the log of 7 million is. That is the same thing as, and you can put that in your calculator, but it's the same thing as doing this. And you go, oh, 10 to the what power is equal to 7 million. Okay, when I put it in my calculator, I just do log of 7 million, and I would get 6.8451. Okay, so that's how you use that log button on your calculator. That's a common log or a base of 10. There are also times where you have to use the anti-log. Now that's what, and I guess I should have left that up there, but let's say I have the log of x. I don't know what I'm taking the log of, but I know it's equal to 6.8451. If I want to find that x, if I want to find the log of what gives me that, all I have to do is do the anti-log of 6.8451. And that's going to give me 7 million. Okay, now let me show you on your calculator how you would do the anti-log. The anti-log is the second button, then your log button. Okay, if you look above the log button on your calculator, it's got like a 10 to the x power. That's your anti-log. So that's how you do that. And then so you do second, log, and then put that number, and you should get a value of that. All right, go ahead and pick up your calculator. If you need to go get your calculator, pause the video and come back. And make sure you can do these on your calculator and you get the same answer. If you're having trouble with it and your calculator is not giving you this answer, you probably need to text me and let me see how your calculator's set up. But I don't anticipate there being any issues on these. It won't matter whether it's in degrees or radians. Okay, so if I do the log of 50,000, it should give me 4.6990. Most of the time they have you round it to 4 places after the decimal. If I have a problem that says the log of x is equal to negative 2.3010, hopefully you know how to do that. Okay, should do second and then log, which is the anti-log of negative 2.3010, should give you an answer of 0.005. Okay, hopefully that's no problem. All right, you're going to use common logs to evaluate expressions and to solve equations. So we're going to start first with just evaluating expressions. Let's say I have the log of 5 times 2 to the 3rd power. Now, if you want to just do your calculator, 2 to the 3rd power is 8, so 8 times 5 is 40. So you could just go log of 40. Well, the log of 40 is equal to 1.6021. If I want to do it this way, I need to understand that multiplication is the same thing addition, and the 3 can be brought to the front of something. So this can be written as the log of 5 plus 3 times the log of 2 If I did that on my calculator, it would be 0.6990 plus 0.9031, which gives me 1.6021. Same thing. Doesn't really matter which way you do it, okay? It works both ways. This way over here seems a whole lot easier to me. All right, what about this one? Oops, hold on. Log of 19 squared over 6. Again, you could just put that into your calculator. The log of parentheses, 19 squared divided by 6 in parentheses, and it would give you 1.7793, okay? If I did it out, I would have 2 times the log of 19 minus, because remember division is like subtraction, the log of 6. This is 2.5575 minus 0.7782, which is 1.7793. Don't know why you would go to that effort when you can do that, but up to you. All right, common logs can be used to find other logs. Let's say I have, well, and here's the format for it. It's pretty cool how it works. That's equal to the log of n, the common log of n, divided by the common log of a. So, like for instance, let's say I want to know the log of base 9 of 1043. All I have to do is do the log of 1043 divided by the log of 9. And that's going to give me the answer. It's 3.1632. Understand, that does not equal the log of, that's entirely different, okay? So to use common log to evaluate another base logarithm, it's the log of this number divided by the log of that number. All right. Then you're going to use these to solve equations. Let's say I have 6 raised to the 3x power is equal to 81. I could look to see if I can get them to have the same base number. I can't, so I'm going to have to take a logarithm of both sides. If I take a logarithm on one side, I have to take it on the other side. So I'm going to go the log of 6 to the 3x power is equal to the log of 81. Now notice these are all common logarithms. 3x gets brought to the front. This is multiplied by the 3x, so I can divide by the log of 6. So I have 3x is equal to, and I can get a value for that. It's 2.4526, just using my calculator. Then I'm going to divide by 3, and I'm going to get 0.8175. Okay. I'll have you try one. These are relatively easy. Just applying algebraic principles. Okay, pause the video, then come back. Make sure you got it right. Alright, I'm going to take the 4x to the front. So I have 4x times the log of 5 equals the log of 73. I'm going to divide by the log of 5. And I get 4x is equal to 2.6658. When I divide by 4, I'm going to get 0.6665. Hopefully that's what you got. All right, we're going to complicate these just a little bit. I'm going to put a variable on both sides, but it's going to be similar principles here. Let's say, and sometimes the book says solve this by graphing. You're not going to solve it by graphing. You're going to solve it algebraically. I'm going to take the log of both sides. Let me make sure that's still recording. Okay. And so the x minus 1 is going to go to the front. And and I have a log of 5. The x is going to go to the front, and I have a log of 2. Okay, you just brought the exponent to the front. Then I'm going to distribute this log of 5. So I've got x times the log of 5 minus the log of 5, because I did this times x and this times 1. And then what I'm going to do is I'm going to bring the parts that have the x, like this is going to get brought over here, and this is going to get brought over there. So I have x times the log of 5 minus x times the log of 2 equals the log of 5, because I'm taking this over there and this over here. I'm going to factor out an x. So I have the log of 5 minus the log of 2, when I factor out the x, is equal to the log of 5. Well, remember, when it's subtraction, it's the same thing as division. So that's the log of 5 over 2 is equal to the log of 5. I'm going to divide, so x is going to equal, I might be running out of room here, the log of 5 divided by the log of 5 over 2. Now, make sure you get your parenthesis right there, because the calculator, when you put the log of 5 in there, it's going to automatically, when you put the log, it's going to automatically give you a parenthesis. Make sure you close the parenthesis behind the one that you're taking the log of. Same thing for the bottom. You can do 5 divided by 2. So when I finish this out, I get x is equal to 1.76. All right. I'm going to have you try one, and then I'll give you your homework. Okay, go ahead and try it. Pause the video and come back. Okay, the x minus 1 goes to the front. So I have the log of 2. And then I have x minus 2 goes to the front. A log of 5. Okay, I'm going to distribute, so I have x times the log of 2 minus the log of 2, and x times the log of 5 minus 2 times the log of 5. All right, I need to take the ones to the x to that side, so this is going to come over here, and then that one's going to come over here. So I'm going to have x times the log of 2 minus x times the log of 5. And I'm going to take this to the other side. So I have a negative 2 log of 5 plus the log of 2. Okay, I'm going to factor out that x. Now I'm going to go ahead, because I'm going to run out of room. This is division. So this is the same thing as saying I pull the x out, and it's a log of 2 divided by 5 is equal to negative 2 times the log of 5 plus the log of 2. Okay, I'm going to do that, and then I'm going to divide it by the log of 2 over 5. You actually could make this into multiplication, because this, well, we'll just leave it like that. You just plug it into your calculator there, okay? Make sure you're careful of your parentheses, so that whole first part goes together before you divide it by the bottom part. And it should give you 2.7565, okay? You could multiply those together if you wanted, and take the negative 2 to that, but I don't know why you would go to the effort of it. Okay, homework. Page 730 through 731, 28 through 51, all. A lot of this is calculator use, but hopefully you're understanding it, okay?